Today's video, we're going to be taking a look at normal distributions through Python. We're going to go over about 7 to 8 different examples, and we're going to cover multiple libraries such as NumPy, Pandas, SciPy, Matplotlib, as well as Seaborn. But before we jump into some of this Python code, let's go over a little bit more information about a normal distribution. All right, so let's take a look at the normal distribution. Now, you'll also see this be called the bell curve or also a Gaussian distribution. So if someone uses one of those terms, just know that they're talking to you about a normal distribution. So the first thing that I think about on a normal distribution is the empirical rule. Now, what this essentially tells you is how much data is in between standard deviations. So it'll take a little bit to memorize, but 68, 95, 99.7. I took statistics in high school, and that was hounded on us so much. And I also competed in math competitions, so I had to know this. But 68, 95, 99.7, right? So 68% of the data lies between the standard deviation of -1 to 1, 95, which is 2 standard deviations, -2 to 2, and 99.7, that's 3 standard deviations, so -3 to 3. And what you'll find is when you are outside of 3 standard deviations to the left or right, those tend to be outliers. And we're going to cover a little bit of outliers in this video. Well, the next slide will cover some of these topics. But regardless, that's one of the really cool things about standard deviation when using a normal distribution. A few other things to note. This is symmetrical left to right, as is a bell curve. You can see if we literally split where we have 0, it would be folded in half. And also, the mean, median, and mode should be about the same, right? All in that center. So it's a little bit of information about this normal distribution. And what is going to be covered on the Python side of things? Well, a histogram as well as a KDE. We'll plot the histogram first, and we'll add in a KDE on top of it. We're going to cover z-scores. We're going to calculate those in a data frame, as well as removing outliers. We're going to cover the CDF to find probabilities at a number or a range. Cover quantiles, quartile, decile, and percentile. And this is going to cover libraries like NumPy, Pandas, SciPy, Matplotlib, as well as Seaborn. And not all of these have specific videos on them right now on the channel, but in the future, each of these will have distinctive videos. So if you want to learn even more about a topic, let's say diving into z-scores, showing manual calculations, multiple examples, and things like that. But I do plan on adding them in the future. So with that being said, I think we're ready to start coding in Python. I'm going to load up Google Colab and let's start coding. All right, so let's start by bringing our imports. So import NumPy as NP, import pandas as PD, and then from scipy.stats, import norm, and then imports matplotlib.pyplot as PLT, imports Seaborn as SNS. I believe that should be everything that we import in this video, and if there's anything else, I will throw it here at the top. All right, so let's take a look at example 1, which is just going to be example 1, generating a normal distribution. And let's go through that. So first thing we're going to do is we'll set our mean equal to 0. We'll set our standard deviation equal to 1. And then you can set the size. I'm just going to go 1000. And also, looks like my 0 didn't type in. Oops. Accidentally put 2 equal signs. All right. So now we have mean 0, standard deviation of 1, size 1000. Now let's generate our data. So all I have to do is go over here and say data equals. We're going to say np.random. Then you say .normal over here. And then you say location equals mean. Then scale equals, we pass in our standard deviation. That. And lastly, size equals our size. So size equals size. So it's going to create a normal distribution around the mean. We're going to use standard deviation, which we set of 1, which the reason why we used 1, if you look at the slides presented before here. And then size, we can set a size to 1000. Awesome. So Let's just take a look at a few different data points. Now, these aren't going to be exact, but we can go over here and first print out our mean. So we can say our mean, and we'll say print np.mean, and pass in our data, right? And you can see our mean isn't exactly 0, but it is going to be pretty close. Now, let's take a look at our median. So median, and all you have to do, np.median, grab that. It's going to be the middle. Hopefully it's close to 0. Otherwise, you not have to change it. But you can see negative 0.04, close enough for me. And lastly, let's just take a look at our standard deviation. So we'll say std dev, like that. Actually, I'll change that up and say standard dev, like that. And what we'll do, same exact thing, np.std, so np.std. We should get close to 1.99. I'm good with that. So just showed you how we can generate normal distribution. Take a look at some of the different stats with NumPy. Now let's take a look at plotting a histogram. So we'll say example to plot a histogram. And plotting is pretty easy, right? So you can go to sns.histoplot, so histplot, then pass in our data that we have, then set our axes, so x label, and then we're gonna say this is value, then our y label, which I'm not gonna type all that out, just change your x to a y. We'll say our frequency, and then title, we'll say histogram, and then just do plt.show, and let's take a look at this. And you can see our histogram, right? So -3 to 3, and goes up, goes down, and it's not perfect, right? But if we want to show that line, right, we'll have to plot a KDE. So I'll plot that, but you can see it's pretty good, right? There's obviously some outliers over here, and we'll explore some outliers a little bit later, which is also really good that not all the data is between -3 and 3, because I don't have no outlier examples. But regardless, let's take a look at example 3, which is plotting a histogram with a KDE. So I'll go over here and say example 3, plot histogram with a KDE. Now, KDE stands for kernel density estimation. And again, it's going to be a smooth curve that shows on top of our histogram over here. It's essentially shows the distribution of data points. So all I'm going to do, I'm going to copy the same code that I had before, and then I'm going to set over here KDE equals true. KDE equals true. And take a look at this now. So now this looks a lot more like our normal distribution we're used to, right? So curve like that, and it goes right down. So I'll just change this histogram with KDE. I apologize for skipping that step, but yeah, so pretty easy, right? To plot this histogram and also plot with this KDE. Now let's take a look at some outliers. So we'll look at example for z-scores first, and then from our z-scores, we can remove any outliers. So what I want to do is go through pandas this time. So we'll say df equals pd.dataframe. And what I'm going to say is pass in our data, and then we'll say columns equal value. Just grab value. I could say values, but value is fine. And just to show you that this worked, df.head. There's a lot of ways to generate this data frame. I've shown a lot of other videos as well, doing a dictionary and then passing it. But regardless, right, df head 0.4 and our values associated with it. Awesome. So let's calculate our z-scores. So we'll say df equals, we'll pass in z-score. Well, not pass in, but title this new column is z-score. And that's going to be equal to, and if you know our z-score calculation, right? So what we're going to do is we're going to say df, and we're going to grab this value over here, right? And that is just our general value. Then we're going to subtract the mean. So minus, and actually I think I should, no, I don't need another pair of quotes. We're going to say minus, and we'll go over here, grab our df value, dot mean, like that. then we're going to divide at the bottom by our standard deviation. So just grab this again, and we'll divide by that and put in our STD like that. And we should now have this column, and I'll just do a df.head again, just to generate that. You can see our value as well as our z-score over here. And this is going to apply to all 1,000 data points that we have in this df data frame. Now, what I'm going to do is we're going to remove these outliers, but I also want to take a look at some of these outliers. So we're going to say example 5, z-scores with outlier removal, right? And the way we can start taking a look at this is we can say outliers equals, and we can take a look at inside of our data frame. So df like this, and make sure we put in some parentheses. So we'll say df, and we'll grab our z-scores. We could literally just go like this. I don't know why I just didn't copy that. We'll have df z-scores like this, and we'll say is less than -3. And we'll add a pipe here on the outside. And we're going to have these parentheses again. And this is an or sign, right? And then we're going to say is greater than 3. So while we classify as an outlier, anything with a z-score less than -3 or greater than 3, right? So the two ends of the extreme spectrum. And if we want to take a look at what these outliers look like, hopefully we don't have a lot. I'll just do a head. I assume we have a couple. If not, we can, we'll say head of 10, right? You never know how many there are in here. And look at that. We have 1, 2, 3, 4 outliers, and some on both ends, right? So our value of being 2.98 over here, it has a z-score of 3.03. So slightly edges that 3 z-score, but then something like -3.689, right? -3.69 z-score, 3.24, -3.24, and -3.08 has a z-score of -3.07. So let's say we want to clean up our data frame now and get rid of these outliers. So what I can say is we can say over here df cleaned equals df, and inside over here just pass in essentially what we had over here, right? So let's just grab this. We're going to put an and sign, and what we're going to do is we're going to change this. So we're going to make this the opposite. So this has to be greater than or equal to -3, and then it has to be less than or equal to 3, right? And then if I do a df.shape on this one, so I say df cleaned.shape, we should have 996, and you can see we have 996. Whereas if I go to df in general and look at our normal shape, so df shape, you can see we have 1,000. So within this data frame, right, I removed the 4 outliers, which we classified an outlier having a z-score greater than 3 or less than -3. And I showed you also how we could build out a brand new column with that z-score. So, all right, so example 6, what we're going to take a look at is CDF to find probabilities. Now, CDF stands for the cumulative distribution function. Essentially what it stands for is the probability that x will have a value less than or equal to x. So our first example, we're going to take a look at -2. Well, let me type up some stuff. Example CDF over here, probabilities. So if we're going to look at example over here with -2, we're going to try to find the probability that the number is -2 or less. What's kind of cool though is you could combine multiple CDFs to find specific ranges. We'll have to do some subtraction for that, and I'll show you that example. So let's say we have CDF over here, -2, okay? And that's going to say equal to norm.cdf. Now, what I need to pass in is our value. So first, the value we're taking a look at, which is -2. And then we're going to set our location. We're just going to say that's the mean. So mean over here. And then next, we need a scale. So scale is going to be our standard deviation. So data.std. Because I didn't save those, I just printed those a little bit earlier, right? So, and I do have an issue over here, unsupported for float. Just double check. Data.mean. Oh, it's because I didn't put the parentheses around std for here. And that should solve that. Okay, so now we just print out our CDF -2. And it tells us we have a 2.3% chance that a value is going to be less than -2, right? It's the probability behind it. Now let's take a look at another value. Let's take a look at 0. So we'll say like CDF 0, and we can just pass in 0 over here, right? And we should have a higher value now. We should have a value that's pretty close to 50%, because if you remember our normal distribution, right, 0 is going to be the center. So if we go over here, CDF of 0, right, 0.51, pretty close. And then if we take a look at +2, we'll say CDF over here of 2, and just pass in 2 over here, we should have a very large value. It's not going to be exactly that second standard deviation, but it's going to be pretty close, right? So print, and we'll have CDF of 2 over here. And you can see it's 97.9%, which is, again, pretty close because we have the 68, 95, 99.7. So not too bad. Okay, now let's take a look at finding a range. So we'll say range using CDF. And what we'll have to do on here is we'll have to set the upper and lower. Let's try to use the CDF to look at the middle 68%. So we'll say upper bound equals -1, or so let's say we have our lower bound equal to -1, and then upper bound equal to 1. Then we'll have to calculate both the CDF. So CDF lower, and I'm just going to say this equals, and grab all this code over here. And instead of 2, we'll just put lower bound over there. And then we'll say CDF higher. And we'll just pass in our upper bound. Okay, so both these are in here. Let's print out both of them. So print our CDF lower. And you can see it's 16.3%. And then our higher print. And you can see it's 85%-ish, right? And now if we want to find that range, we'll say CDF range equals, and then we just have to subtract them. So CDF higher minus CDF lower. And I'm hoping we get around 68 in general. So we'll say print and see what this looks like. And 68.6%. So that first standard deviation of -1 to 1. Again, these numbers don't exactly line up to our standard deviation across the board, but pretty close, right? 68.6%. So now what I want to take a look at is quantiles. And this is going to be our 7th example. So example 7, quantiles. And so there's 3 different types of quantiles, right? You have your quartiles, you have your deciles, and then you also have your percentiles. So let's go through each of these examples. Your quartile is going to be 25%, your decile is going to be 10%, whereas your percentile is going to be in increments of 1%. So let's go over our first one, which is quartiles. So we'll say quartiles, and this is abbreviated with a Q. So we're going to look at Q1, and that's going to be equals to np.percentile, and then you pass in our data, and then you specify where this is at. Now, your quartile can technically be a decile and a percentile at 50, right? Because 50, which is the median, fits the criteria of being an increment of 1 and increment of 10. Now, we're using percentile over here because percentile is a 1, and a percentile will fit into decile as well as a quartile. Okay, so let's take a look at 25% over here, and then we'll say print. We'll have Q1, right? Oh, I just copied that. But regardless, at the point -0.67, 25% of our data lies below that. Now, let's take a look at our decile. So decile over here. Again, I don't know why I copied that, but we'll say our deciles like this. And this is abbreviated with a capital D. So let's take a look at the 9th decile. So 90%, right? And we're going to say np.percentile. So percentile, and pass in our data, and then also 90. right? And if we want to see that, so print, and we'll print out D9, you can see at point 1.259, almost 1.26, 90% of our data lies at that number or lower. Lastly, let's take a look at a percentile in general. So go to percentile, and what we'll take a look at is capital P, and we'll put 11. So that's going to be equal to np.percentile. So percentile, pass in data and 11. And 11% of our data is going to be below print P11, value negative 1.17. So to recap what we've covered so far in this video, right? First, showed you how to generate a random normal distribution through NumPy, right? Your mean, standard deviation, and your size over here. And it won't exactly line up because, again, it is random, but you're going to get pretty close. Then I showed you how we can calculate the mean, median, and standard deviation using NumPy. It makes it super, super easy. Plotting a histogram, right? And this is our histogram of that random generated data. We can also have a KDE printed on top of it, which shows you the curve, which you may be more familiar with, right? Then we covered z-scores. We use a Pandas DataFrame for that example, right? So I showed you how to calculate a z-score for each data point. And then we covered also on how we can remove outliers. An outlier on the z-score side of things is considered something less than -3 or greater than 3, right? So showed you how we can find those exactly and then remove them from our data frame. And you can see we removed 4 outliers. Now we take a look also at some CDF probabilities. So we took a look at, for example, -2, right? What's the percentage that the value would be -2 or lower? And we found that, then 0 and 2. And then I showed you how we can find a range, right? Let's say we want to have a value between -1 and 1. We found that to be about 68%, which lines up with that 68, 95, 99.7, which I demonstrated in that PowerPoint. Lastly, it showed you quantiles, so you can take a look specifically at a quartile, a decile, or a percentile. And that's literally easy. You just do np.percentile, pass in your data, and then specify a number 1 through 99. And I showed you those 3 examples, Q, D, as well as P. If you guys enjoyed this video on normal distributions and you learned something new, if you did, make sure to subscribe to the channel. My goals is to reach 100,000 subscribers in 2025. And I'm doing that by uploading at least 3 different data science focused videos every single week. Now, if you want to learn even more about statistics that can be applied to data science, I have a few videos linked down below in the description, as well as a playlist that's going to be linked right over here. Make sure to check those out.